Welcome to homework.
So here in this problem we are given that the steam enters an adiabatic turbine at pressure 800 psi. So P1 is 800 psi and temperature we are given as 900 degree Fahrenheit. And it leaves with the pressure 40 psi. And we have to calculate the maximum amount of work that a turbine can deliver. So to solve this problem, we'll be using the table A6E and A4E to get the required input data. So the initial state we are given as that P1 is 800 psi and temperature is 900 Fahrenheit. So by these two data, we can calculate the value of H1 and S1 at the state. So H1 will be 1456.0 BTU over LBM, and the entropy will be 1.6413 BTU over LBM Rankine. And the state 2 we are given as that P2 is equals to 40 psi, and since we have to calculate the maximum amount of work, so we have to consider this turbine to be a reversible turbine. So we can say that entropy generation would be 0, or we can say that S2 will be equals to S1, and that is 1.6413 BTU over LBM Rankine. So from these two values we can calculate the value of H2. So before calculating the value of H2, we have to calculate the dryness fraction at this point, that is X2 we have to calculate. So X2 will be S2 minus SF divided by SFG. So we can plug these values SF and SFG corresponding to this pressure 40 psi. So it will be S2 will be S2 we know it is 1.6413 minus SF will be 0.39213 divided by SFG is 1.28448. So after solving this, we'll get the value of X2 as 0.9725. Now we can easily calculate the value of a specific enthalpy at state 2, and that will be equals to HF plus X2 times HFG. So HF from the table it will be 236.14 plus X2 is 0.9725 times HFG is 933.69. So after solving this, we'll get the value of H2 as 1144.2 BTU over LBM. Now we'll going to apply the energy balance equation to find the work output. And we know the standard equation is rate of energy input minus the rate of energy output. It will be equals to the change in energy of the system. Since we are given that the turbine is steady, so this thing would be 0. So energy in will be equals to energy out. So energy in we have the enthalpy, that is m dot h1 is equals to output, we have the work output, and the enthalpy m dot h2. So from here work output will be equals to m dot h1 minus h2, and since the mass flow rate is not given, so we'll be dividing the work output with mass flow rate. So we'll get the work output, this is the unit will be BTU over LBM for the work output, and it will be H1 minus H2. So we can plug it here, all the values. Work output will be 1456.0 minus 1144.2, and the unit is BTU over LBM. So after subtracting these two numbers, we'll get the work output as 311.8 BTU over LBM. So this is the final answer for the given problem. I hope you got the problem. Thank you.